All right, so this is Rational Expressions and Equations, Lesson 1. It's all about non-permissible values. And the way the non-permissible values work is that they're the things in the denominator of an expression. An expression is where we have x's and variables, and a rational expression is when we have variables in the top and bottom. So with rational numbers, they're fractions. They're things that have something in the top and something in the bottom. A rational expression means that we have polynomials with variables, one in the numerator and one in the denominator. So one of the first things that we have to work with is being able to do our factoring stuff. Again, in 30-2, all you need to be able to do to factor is difference of squares and greatest common factor. So let's practice this out. This is greatest common factor of these two things is going to be an 8, which leaves an x minus 3. Greatest common factor of this is actually the 2 and the x. And x can come out as well because there are x's in both places. This is going to leave me with 5x squared here and 1 there. This is now a difference of squares. There's nothing common about it, but it is a difference of squares. So it's going to be the square root of the first minus the square root of the second, square root of the first plus the square root of the second. In this one, I first take out my greatest common factor, which is an x. That leaves me with x squared minus 1. But hey, that's a difference of squares. So x times x minus 1 times x plus 1, and that's the solution. Non-permissible values. So if we have the rational expression 6 over x, what's the value in x is 2? Well, hey, when we put in x is 2, 6 divided by 2 is 3. What about when we put in x equals 0? Well, 6 divided by 0, that doesn't make any sense. I've got 6 gummy bears. How many ways can I group them into 0 groups? Well, I can't group them into 0 groups. If I just don't group them, it's one group of 6. So there's the problem with that. That is just undefined. One of my favorite things to do is to ask Siri about what 6 divided by 0 is, or what 0 divided by 0 is. And Apple designers have set her up to do a bunch of the fun stuff. So anyway, what we're going to do is we're going to put in these pieces. So we're going to evaluate at this thing. If I put in 3, it's 2. If I put in 2, 6 divided by 2 is 3. 6 divided by 1 is 6. 6 divided by 0 is undefined, or does not exist. 6 divided by negative 1 is negative 6, negative 3. And I think there's one more over there. Negative 2. Let's see if I can get everything to fit on one. Oh, look at this. Isn't that great? Over in this one, 10x over x plus 3. 10 times 3 is 30, divided by 3 plus 3 is 6. So this is be if I did this. And I won't do this for all of them because it'll take too long. So I'm just going to show you kind of in shorthand there. But that would have a value of 5. If I put in a 2, 20 over 5, that's 4. If I put in a 1, 10 over 4, that's 5 halves, or 2.5. If I put in 0, I get 0 over 3, which is fine. 0 in the numerator is all fine. You have 0 cookies. How many ways do you group them into 3? Well, you have 3 groups that all contain 0 cookies. Nobody gets any cookies, and that's sad, but it mathematically works out. Negative 1. Negative 10 over 2 is going to be negative 5. Negative 2 is going to be negative 20 over 1. If I put in negative 3, I get negative 30 over 0. Wait a sec, I can't do that. That does not exist. Here we go. 8 over x minus 1, x plus 2. If I put in 3, 3 minus 1 is 2, so 2 times something. And I'll show this top one, and then we'll go through it faster. 3 plus 2 is 5. 5 times 2 is 10. So this becomes 8 over 10, or 4/5. If I put in 2, 2 minus 1 is 1. 2 plus 2 is 4, so it's 8 over 4, which is 2. If I put in 1, 1 minus 1 is 0, and 8, I can't divide by 0. All right, it does not exist. If I put in 0, I get negative 1 times positive 2 is negative 2. 8 over negative 2 is negative 4. If If I put in -1 plus or minus 1 is -2, and -1 plus 2 is -1 plus 2 is +1. So -2 times +1 is still -2, so this is also -4. If I put in -2, hey, wait a sec, that does not exist again. Can't divide by 0. If I put in -3, -3 or minus 1 is -4. -3 plus 2, -3 plus 2, -3 plus 2 is -1. -1 times a -4 is +4. So my overall denominator is a +4. 8 over +4 is 2. All right. In this one, 3 minus 3 is 0 over 3 times 3 minus 2. 3 minus 2 is 1 times 3 is 3. So 0 over 3, which is just 0. Hey, that's cool. All good. Zero's in the numerator? Fine. No worries. Zero's in the denominator? That does not exist mathematically. At least not until later. In university, we'll start to challenge you a little bit, dividing by 0. Actually, even in calculus, we start really dividing by 0 and getting things to happen. But not in this course. Okay. 2 minus 3 is -1, so I have a numerator of -1 in this case. 2 times 0 in my denominator. So this would be like -1 over 2 times 0. Wait a sec. As soon as I've got a 0 down there, it's a does not exist. 1 in the numerator is -2. 1 in the denominator is 1 times 1 minus 2, which is -1. 1 times -1 is just 1. Well, -1. And then -2 over -1 is just +2. I put in 0. That's a deal breaker because the 0 in the denominator makes this thing 0 and the whole thing 0. -1, -4 in the numerator. -4 over -1 times -1 minus 2, which is -3, +3, so -4/3. Oh, this is taxing my mental math this early in the morning. Okay, -2 minus 3 is -5. -2 times -4 is 8, so -5/8. And we put in -3. -6 over -3 times -5, -15, which is -2/5. -2/5? Yeah. I'm mostly sure of that. You know, I'm just going to cheat for that last row. I'm going to show you some things. I'm going to go into my calculator, turn it on, hit y equals, clear that out. Now, when you're typing things in your calculator, bracket your entire numerator. X minus 3, close bracket. I'm also going to bracket my entire denominator. X, bracket, X minus 2, close bracket, close bracket. There we go. Now, moment of truth, let's go to the table. And I'm going to start at -3. So at +3, this is kind of backwards here, but +3, the value is 0. That's what I got. Check. +2, error. That's the same as the does not exist. That's what your calculator tells you. +1 is 2, does not exist. -1.333 is the same as -4/3. If you don't believe me, I can type this into here. Hey, look, it worked. Back to my table. So I was right on this one as well. 0.625 is 5/8, and -2/5 is -0.4. Look at me go. It's almost like I know what I'm doing. Okay, so now that we've got that in there, I'm just going to scroll down here. So the values for which it was not defined. This one was at x equals 0. This one was x equals -3. This one had 2. 1 and -2. This one had 2 also, 0 and 2. We can start to see how these line up, right, with the zeros of your denominator. So without going any further, let's see what did I skip here. Use the results, make a connection. Zeros of denominator. Okay. State the values for which the variable of the rational expression is not defined. This one's going to just be at a factor of x minus 6, it means x equals 6. Hopefully you can get to the point where you just look at the factor and you're like, oh yeah, that's that. If not, what you can always do is go like this, x minus 6 equals 0. And then what I'm going to do is just add 6 to both sides. That works. In this case, now I've got two non-permissibles, which is going to be -5 and +9. And again, we write non-permissibles with x cannot equal 6. So the non-permissible value is 6, which means x cannot equal 6. So we talk about non-permissible values and limitations or restrictions. Very well. All right. So in this one, it would be x cannot equal -5 and x cannot equal +9. But because mathematicians are lazy, we can just usually go, x cannot equal 5 or 9. Sometimes we'll have to factor our denominator to get it to work. So I'm going to first look at this, x plus 1 divided by 5x is my common factor. So when I take that out, I'm going to have x minus 1. So my non-permissibles are, whenever you have just a lone x by itself, it's just x cannot equal 0. And in this case, x cannot equal +1. So that's the restrictions. My non-permissible values are 0 and 1. And my restrictions are really technically that. Now, basically the same information. So if you wrote one instead of the other, I probably wouldn't take off a point. Determine non-permissibles in each of these places. First things I need to do is factor, factor, factor. When you have negatives everywhere, it's easier to take out the negative as well. So I'm going to take out a -1, actually a -2. What I'm left with is then x plus 2. Here, I'm going to take out a p, and then I have 4p minus 1. And therefore, here my restriction was x cannot equal -2, or non-permissible of -2. Here, p cannot equal 0. That's that one. And this is a little bit harder to see. It's going to be +1/4. You flip the sign and then go this over this. Or you could go 4p minus 1 is not equal to 0, and then add 1 to both sides, and then divide by 4. You get p cannot equal +1/4. Either way you get there works. This one is my completing the square. That's going to be that. So a cannot equal 7 or -7. And lastly up here, x minus 2 over 2 times x squared plus 4. Now x squared plus 4 looks like a difference in squares. It should set off all those flags for you, but it's not because it's a plus. X squared minus 4 would go to x minus 2x plus 2. This thing is never equal to 0. It just doesn't happen. X squared plus 4 is never going to equal 0. Because every value that I have for x, if I square it, it's still some number, and it's positive. If I add 4 to it, it's just going to go up. So no restrictions at all. So I've already stated my restrictions up here. But x cannot equal -2. P cannot equal 0 or 1/4. A cannot equal 7 or -7. And here x is fine. So no limitations. Write a rational expression with each of these things. The variable is x, and a non-permissible is 3. So it's going to be something like that, x minus 3. If I have a variable as a, its non-permissibles are 0 and 4, I could have something like this. The variable is p, and my non-permissible is 1/3. I could go p minus 1/3. That's totally fine. Or I could multiply a 3 into that and get p. And actually, my numerator doesn't matter. So let's stick to making my numerators all 1. Technically, I could have made it anything, but let's just stick to 1s. I could also do this, 3p minus 1. That'd be fine also. I would accept both those solutions. Hopefully that makes sense. Come and get me if you need help, and we'll rock.